46, we want to figure out what cosine of negative pi over 3 would be, which cosine of negative pi over 3, we look at negative pi over 3, which that's actually not really to scale. Negative pi over 3 is a third of the way to pi, which is down here. You can look at your unit circle, or you can make a special right triangle. We know this reference angle will be 60 because this is over 3, which means this is negative square root of 3, 2, 1. And so cosine is 1/2. Okay, so this part right here is 1/2. So we want to figure out what is the inverse cosine of 1/2. Well, it would be what we just had, except that the inverse cosine function does not ever return values that aren't in the first and second quadrant. So what we would have to do is we would have to say, okay, where it's positive 1/2 for cosine, the other place that can happen is up here. Okay, and that's the answer we are looking for. And so that would be positive pi over 3. If it wasn't for the fact that this is a negative pi over 3 and we're doing cosines, these would just cancel each other out and leave us with our angle. Okay, and so actually if it was like sine or tangent and they asked us this, they would just cancel out and leave us with the angle, whether it's positive or negative. Then we would be concerned with, like, did they give us something in the second or third quadrant? So the problem is they gave us something in the fourth quadrant, so we had to think about what's the same thing in either the first or second quadrant. 47, we're going to make a generic triangle that has a tangent of an arctangent of u over 1. And so we need to label one of our angles theta and then say tangent is opposite over adjacent, so that's u and that's 1. So all we need to do is the Pythagorean Theorem to find the hypotenuse. So it'd be the square root of u squared plus 1, which cannot be simplified. Sine of theta now, because we didn't find theta, but we set up a triangle with it. Sine of theta is opposite over hypotenuse, which is u over square root of u squared plus 1. You do not need to rationalize that. I would personally prefer that you not do it. That's our answer. From a boat on the lake, the angle of elevation to the top of the cliff is 24 degrees 47 minutes. So something like this, where the angle of elevation from the boat to the cliff is 27 degrees 47 minutes. So someone in the boat is looking up at the cliff, and that tells us what that angle is. If the base of the cliff, which is here, is 1751 feet from the boat, which means this side is 1751, how high is the cliff to the nearest foot? So what we know is the adjacent side, and what we're trying to find is the opposite side, which means we want to use tangent of our angle is x over 1751. So we want to multiply both sides by 1751. So you can actually type the degrees and minutes in on your calculator by going on the 84s to the second apps menu. It has a degree mark, and a minute mark. You just type it in. On the Inspires, you have to use like the exclamation point menu or the pi menu. Just press a bunch of buttons until you find it on the Inspire. Oh, I guess I should probably type this in. 1751 tan 24 degrees 47 minutes. And at this point on the test, you would want to switch to degree mode. This one might do okay, even if it's in radian mode, because we're telling it to use degrees. But I get 808 to the nearest foot, 808 feet. Okay, the whole rest of the test, you should be in degrees. So, solve the triangle. We have an angle, and a side. We can draw the triangle if that would help us, but you know, there is a formula, right? That's sine A, so sine 42 over little a, which we don't know, sine B over little b, which we also don't, oh no, we do know b, is 8. Now, because we know two of the angles, we can do 180 minus those two angles and figure out what our third angle is, which is 104. And then we don't know C. So we would want to do these. I put plus signs for no good reason. Those are equal signs. So we do these first two and cross multiply to find little a. So we would do 8 sine 42 divided by sine of 34. So make sure that you're in degree mode. I get 9.573. And then we could actually use like the first and third now that we know A, but it'd be better to use these two to reduce our chance of rounding error. So 8 sine 104 equals C sine 34. So we're doing 8 sine 104 divided by sine 34. $13.881. So the three parts we needed were big C, little c, which we have all of those right there. Okay, two triangles can be formed using the given measurement. Solve both triangles. So notice they didn't ask us to figure out how many triangles they were, which is helpful, but now we do have to do some work and figure out both of the triangles. So what we're going to do is set up law of sines. And we're going to use the first two and do 15 sine 59 equals 14 sine B. So I need to divide by 14, and whenever we get 15 sine 59 divided by 14 on our calculator, we need to do inverse sine of our answer. So second sine, second answer, and we get 66.6923. So just 2. Now, this is actually our first angle B. Our second angle B, we're going to get by doing 180 minus what we just got on the calculator. Okay, 180 minus second answer is 113.308. Okay, and that's what B2 is. So what you have to remember on this is you find the first angle like normal, but to find the second angle you do 180 minus it, because that's the answer our calculator doesn't know is there, because our calculator can only give us one answer. Now we want to go through and find big C and little c for each. And so big C, all of our angles have to add up to 180. And so we would do 180 minus 59 minus 66.692, which is 54.308. And so then we can set up, I would use what you started off knowing, sine 59 over 14 equals sine of 54.308 over C1, because we're still on our first triangle. And then cross multiply, so 14 sine 54.308 divided by sine 59, which gives 13.265. Okay, so that is all of our information for our first triangle. Now we go back to our second one. And if we hadn't already, we would find B2, because you take the number that you got on the calculator, you do 180 minus 113.308, then we are going to subtract from 180, this time using 113.308. So 180 minus 113.308 minus 59 is 7.692. And then little c, we're going to do what we did here, but with 7.692 in this spot. So we cross multiply and get 14 sine 7.692 divided by sine 59, which is 2.186. So that's our second values for our triangle. 51, two tracking stations are on the equator, 124 miles apart. So the equator in general is like a horizontal line, you know, like it's a line that runs from west to east. And so these stations are 124 miles apart. A weather balloon is located on a bearing of north 34 degrees east from the western station. So I want to think about north is straight up and down. And so 34 degrees east of north puts us around this general area. And then on a bearing of north 16 degrees east from the eastern station. So this is north 16 degrees. I'm going to go ahead and draw this a little bit not to scale, because if I don't, then I'm going to have to make my triangles go really high, or my triangle is going to be really tall in order to get it to meet. So, you know, they would meet up here. Here's where the weather balloon is. And we want to know how far is the weather balloon from the western station, because this is the west side, this is the east side. We want to know this value right here. And so we would look at this and say, well, what angles do we know inside of our triangle that we just drew? This is 34, so 90 minus 34 gives us this angle inside. Okay, 90 minus 16, which is 74, goes here. And so we know two angles, which means we can actually find the third, which would be helpful. 180 minus 56 minus 74 is 50. And so we can label our triangle A, B, and C if that would help. But another way of thinking of the law of sines is it's sine of angle 50 over the side that's across from it, which is 124, which means we need to use 74 with x. So sine 74 over x. So we're going to cross multiply and do 124 sine 74 divided by sine 50, which gives us 155.6. and our units are miles. And I'm rounding to 0.6 because there's a bunch of 9s after that. So 52. We are going to solve this triangle, and there's 3 sides, which it doesn't tell us what to use for our 3 sides. I mean, which one, law of sines or law of cosines, to use, but hopefully you realize that we need to use law of cosines when we're given side, side, side. The best thing to do is to pick out your biggest side, and that's the angle we're going to solve for. So we're going to use the b squared equals version of this. The reason we use the biggest side first is because if we do that, then after this we can switch back to the law of sines if we like it better or whatever. But if we found A first and then switch to the law of sines, we might not get the right answers, and that would be bad. Okay, so when we're doing this, we want to subtract 5 squared and we want to subtract 8 squared over. Then we want to divide by everything that's left in front of cosine. So -2 times 5 times 8. When you put this in the calculator, you're probably going to put 11 squared minus 5 squared minus 8 squared in and press enter. When you divide by this, please, please, please put this in parentheses when you divide. And then you're going to do the inverse cosine of your answer. And that will give you angle B. So let me do that real quick. 11 squared minus 5 squared minus 8 squared, enter, divided by, open parentheses, -2 times 5 times 8, close parentheses. I get -0.4, but I need to do second cosine, second answer, and that gives me 113.578. And that's angle B. Now I can either switch to the law of sines or I can keep using law of cosines, and it doesn't matter which way you do it as long as you get the biggest angle first. And really there's only one more step to do before we can just subtract from 180 to find the third angle. So let's say we want to switch back to the law of sines. We would do sine of what we just found over
Hi, my name is Melinda Langley. Follow me on Twitter. Thanks.
Okay, so anyway, over B, which is 11, equals, and then we're going to do, it doesn't matter which one we do. We can do A or C. So I like to go from biggest to smallest, so we'll do C now. So we're going to find sine of big C over 8, cross multiply. So 8 sine 113.578 divided by 11. Second sine, second answer is 41.802. And then now we know 2 of our angles, and we just need to subtract them from 180. So I get 24.62 degrees. There's angle A, angle B, angle C. You need to find the area on 53 and 54. So if they give us an angle, a side, and a side, the angle should be a different letter than the 2 sides. Otherwise, we would have to solve for more of the triangle. And so our formula is 1/2 times side, and then we do sine of the angle that they give me. So that would just go in my calculator, and I get 134.058 feet squared. 54 is going to end up being a large number because our sides are large. Heron's formula is the one with the s's. So you start off by doing A plus B plus C over 2. And that gives you S. Which is 310. And then you do 310 times 310 minus A, which is 240. The web camera's not on. You're going to have to say something if you want to be on that video. Times 310 minus 255. Sorry, I ran out of room there. So we type all that into our calculator. Just keep on typing.
Plug and chug. And then your answer will be 14,859. How many decimals we need? All of it?
3.
3.256. So that answer again is 14,859.256. Boom. That's how you do math.
Final question, number 55. Two boats leave a dock together, each traveling in a straight line.
Where are they going, K-Steve?
I don't know. Wherever floats their boat.
Oh!
Okay. I don't actually know if you asking me where the boats were going came like on the mic, but
anyway, before all that, I asked her where these boats were going.
Yeah, and I said wherever floats their boats. Anyway.
Hey, is this algebra 2?
No, it's pre-calc.
Oh. Deuces Precalc. This has been Chase Coley coming at you live.
Thanks. Bye, Chase.
Bye.
Two boats leave a dock together, each traveling in a straight line. One boat travels at 20 miles per hour and the other at 10 miles per hour. If the angle between their courses measures 53.6 degrees, how far apart are they after 27 minutes? So it doesn't really matter which direction that we draw them going, as long as we realize the angle between is 53.6 degrees. And we want to know that at the end of this, how far apart they are, which is this side of our triangle. So in order to do this, we can actually figure out these two other sides of our triangle, because one of them is traveling at 20 miles per hour for 27 minutes. The other is at 10 miles per hour for 27 minutes. The problem is that we're in miles per hour. They gave us minutes, so we need to figure out how many hours 27 minutes is. So that means doing 27 divided by 60, which is 0.45 hours. So one side will be 20 times 0.45. The other side will be 10 times 0.45. Well, 10 times 0.45 is pretty easy. That's 4.5. 20 times 4.5 then should be 9. How convenient. And then we'll use the law of cosines, because this is side angle side, to find our third side. So x squared will equal 9 squared plus 4.5 squared minus 2 times 9 times 4.5 cosine 53.6. And so we'll just type all this in and square root it when we're done. .293, and that would be miles.